Hey guys, let's check out conducting a z-test. Now in SALT it's kind of confusing because there's no z-test option. WeatherWise is a magazine published by the American Meteorological Society. One issue gives a rating system used to classify nor'easter storms that frequently hit New England and can cause much damage near the ocean. A severe storm has an average peak wave of mu equals 16.4 feet for waves hitting the shore. Suppose a nor'easter is in progress at the severe storm class rating. Peak wave heights are usually measured from land using binoculars off fixed cement piers. Suppose that a reading of 37 waves showed an average wave height of 16.9 feet. Previous studies of severe storms indicate that sigma, that's population standard deviation, is 3.5 feet. Does this information suggest that the storm is perhaps temporarily increasing above the severe rating? Use a significance level of alpha equals 0.01. Alright, so I went ahead and put 0.01 in for the significance level. That's always going to be the decimal form of alpha. If it's given as a decimal, just copy it. If it's given as a percent, change it to a decimal by dividing by 100 and enter that number. But we do need to make a note that population mean is 16.4, so that's your null hypothesis. And then increasing is the key word that we're looking for the alternative hypothesis. So null hypothesis is the known data. The alternative hypothesis is our research question. We're looking for increasing. So this top hypothesis set is the one we're after. Because we have a sample size greater than 30, and we also know that sigma, we're going to use a standard normal, large sample size, and sigma is known. Now, when you go into SALT, inferential statistics, there is no z-test option in here. So I'm going to stick with one sample t-test. We want to do hypothesis test. Our sample gave us an average of 16.9 feet for the wave height. Now, even though this says sample standard deviation, our population standard deviation was 3.5 feet, sample size 37. The null hypothesis is 16.4 feet, and we're testing whether the wave height of our sample is greater than that. So let's generate results. All right, our t-statistic, 0.868, rounded to two decimal places, that's 0.087. 0.087. Our p-value is 0.195. 0.195 falls between these two values. Now, because our alternative hypothesis is greater than, we're only looking for shading to the right. This is the only one that has shading to the right of 0.87. So that's the graph to select. And because P is greater than alpha, remember P is 0.195, that's greater than alpha, we fail to reject the null hypothesis. Our data is inconclusive or not statistically significant. Doesn't mean we're wrong, it's just our sample doesn't give us enough evidence to reject the null. So we fail to reject the null. We don't have enough evidence to conclude that the storm is increasing above the severe rate. Now, to conduct this on your graphing calculators, let me scroll back up. We're going to go into stat test z-test because we know sigma. We're going to leave it on stats. Okay, our null hypothesis is peak wave height of 16.4. Now notice this time they give us an actual place for sigma instead of S. Sigma's 3.5. The average from our sample was 16.9. Our sample size was 37. This time we're looking for greater than. Our alternative is to be greater than. Swing over to greater than your null hypothesis average, and then calculate. Our z-value is 0.868, which again rounds to 0.87. Our p-value is 0.192. It's a little bit different from the SALT, but I couldn't find where we had a z-test option on SALT. If you want to be careful when you're doing a z-test, you might want to do it here on the graphing calculator just so that you know that you've picked a z-test instead of relying on a t-test to be accurate. Even though central limit theorem covers this. But anyway, choose the right interval for your p-value. And since p is greater than alpha, p is greater than alpha, do not reject the null. We do not have enough evidence. Do not reject, not statistically significant, insufficient evidence. Those will all go hand in hand.